sorry, that's a little crooked. All I know is my sample, so we're going to examine the scatter plot of the sample for linearity. Okay, which means I will want to copy that little scatter plot down. And that seemed adequately linear to me. Okay, I have to flip the page to go to the third condition. Are you ready? Not yet. Okay, here we go. This is my little explanation for the standard deviation. I think you'll get it. I'm trying to get in a certain window on the recording, which is why I'm kind of moving things around a little bit. All right. Condition number 3. The standard deviation for the population responses is constant, is always the same. I'm going to explain what I mean, and then I'll tell you how we can check to see if we've met this condition. Okay, so here is not my sample that we did. Here is the whole population of possible NEA changes. There's one. There's one. There's one. And the possible fat gain responses that could go with that. So maybe here's one, there's a whole bunch of responses in my population that could go with that NEA. There's a whole bunch of responses that could go with that input. There's a whole bunch of responses that could go with that input. That on average, put together, those will make my population, at least there's this regression line. Somehow now the video, oh, there we go. Right. Okay. When I look at these outputs, all the possible outputs here, they have a mean, should be right here in the middle. They have a standard deviation. The standard deviation for the whole population of those, and for these, and for these, all has to be the same. Okay, so that's what I'm checking for. This is a little heady, but this is what I'm checking for. How can I verify this? You're going to check the residuals for even scattering and no spray pattern. Do you remember what the spray pattern was? Yeah, so they were real close to the horizontal axis on one side, and then they started getting far away. Okay? So if they're close over here and they're far away over here, then my standard deviation for these may be different than my standard deviation for those. So that's how I'm checking to see if the standard deviations would be approximately the same. Yes, sir. Mm-hmm. No, this is my set. This is how I'm going to check to see, because for the population I can't check. I don't have the numbers for the population. So I look at my sample. My sample will supposedly mimic my population a little bit. So I'm looking at my sample residuals, and I don't want a spray pattern, and I want them pretty evenly scattered. And ours were pretty good. I need to go back and plot mine. Just to make sure I get you a decent plot here. Second list, number 7, clear out my y equals. So, pretty good even spray here. We have this one that's kind of a little bit of an outlier, maybe end up being a problem. But anyway, I'll kind of, check that. I'll do my check for that. Not bad here. Okay. Checking condition number 4. I'm going to go back to this little graph here. My graph number 4 is that all of the outputs, all the y's, all the responses are normally distributed. Okay? Conceptually, what do I mean? Let me go back to this graph and look at my responses. There should be most of them close to this line here, and then a few off in the tails. So if I looked at that distribution, I'd find it centered here on the line, and a few little dots off to the side. So for this one too, centered, a high point there at my least squares regression line, very few dots way out here. Okay, so there's my concept. It's a very familiar drawing that you'll see in many stats classes, many stats textbooks. This is what it means. Okay, how can I check for this? We will look at the distribution of the residuals. And we'll check the distribution of the residuals for normality. We can either use a box plot or a histogram. That is the 4th condition we had to check. Yeah. So, like I say, these checking conditions are a little harder than the others. All right, so let me go to my graphing calculator. Okay, if I want to check the distribution of the residuals, I think I'll just make a box plot. And for my list, I'll put in that residual list. And then I'll do a zoom stat. Okay. This one's skewed. Can you tell that this box plot shows a skewed distribution? Yeah. Yeah. So I go into plot 1, and you can choose either the histogram or the box plot. This time I think I'll choose the histogram. And then in your list, your X list, put resid. So that's second list, number 7. Did you ever run the regression? Oh, well, then it should be there. Okay. Oh, okay. Find your resid list. It may be in a different place. So I see it even better with the histogram. I see the skew. Haven't met conditions. we're not going to do the procedure to